you've probably had an experience where getting this data from machines is really freaking hard. And the question is, why is it so difficult? Well, discrete manufacturing introduces significant complexity when it comes to machine connectivity. And it really all starts with the variability of the machines in discrete manufacturing plants. There are many different machine manufacturers, and no one plant only has one brand. If you do, good for you. You found something that you love. But most people, have a number of different types of machines. There are different ranges. They range from old to new with modern control systems, older control systems to 20, 30-year-old machines with limited control capabilities. We've had customers that have come to us with machines as old as World War II. So, connecting to and collecting data from all these various plant assets is a significant challenge, considering many of these machines were never even designed to provide data for the kind of holistic, factory or enterprise-wide analytics solutions that companies are focused on enabling today, right? So the initial challenge here that we're dealing with is just data variety, right? Whether it's a modern machine that speaks, MT Connect, FANUC, OPC UA, communicates through Ethernet IP, Modbus TCP for any of the other people that understand what I'm talking about on this attendees list. I appreciate you. For those that you don't, all you need to really understand is that these machines essentially speak hundreds of different languages. And even those that are standardized into one language, it varies from one machine to another. So not only are there many distinct types of equipment, from lathes to mills to plastic injection molding to stamping to laser cutting to robotics, but depending on the mechanisms available for acquiring the data from those systems, the data points could be actually quite diverse. So to provide effective tools for analyzing this data across these different distinct systems, the data has to be transformed into a common model so it can actually be connected and used, and ingested by another system so it makes sense. Imagine trying to translate essentially all of not just the human languages of the world, but all the animal languages as well. And that's sort of the challenge that you face when you're dealing with machine connectivity. Not only does each control have its own mechanism for capturing data, but the data points can differ literally by the family to make the model of the machine using that control, as well as the version of the software running on that control. It really is, that different. Fortunately, that's our problem, not yours, if you use machine metrics. But it's a huge challenge when it comes to just making it easy to get this data. The second challenge that we've seen is just the data volume. So manufacturing equipment and discrete manufacturing equipment in particular is, as you're aware, very complex. A machine is a large system of components that work in coordination that result in hundreds of distinct data points that change constantly. So depending on what you want to do with that data, there may be situations where it's required to capture data at different speeds. Is it 1 hertz? Do you need 1,000 hertz? Many times, if you just want to visualize, is my machine running or not, it might be good enough just to have a pulse check, right? To understand, every second, my machine is running. You can capture that data and push it to the cloud using a basic, hertz rate of data capture. If you want to be able to visualize microfractures that lead to, potentially lead to a scrap part through a bad cut, those microfractures are often only visible through, upwards of 1,000 hertz, right? Or a kilohertz of data capture from these machines. So when you're looking for machine connectivity, you have to consider understanding what actual speed the data has to be captured at in order to support the use cases that you're looking to do. Many machines don't support all these different speeds. And so being able to solve that problem is another challenge that manufacturers face when you're looking to enable use cases. And lastly, to speak a little bit more about that, while some systems can provide value with, let's say, low fidelity and even high latency data, certain use cases do require data to be more real time to be effective. So the data speed itself is critical. And just to speak to whereas with volume, right, the system that you are using must be capable of not just hosting, but storing all the data that you're capturing in real time, capable of performing complex processing where it's most appropriate at both the edge or the cloud, because there's so much data that you're collecting. The speed that the data is being collected is equally important and equally challenging, right? So edge technology is oftentimes required for certain machine connectivity to process these high volumes of data, whether it be at the millisecond or less, to drive action for potentially prevent damages to the machine or in the workplace. So between the data variety, data volume, or the data speed, manufacturers have a lot of challenges when it comes to capturing data from these machines.